Let there be a reflection across line L, and there be a translation along vector AB. If S denotes the black figure, compare the translation followed by the reflection with the reflection followed by the translation. So what we're going to do is we're going to do one thing first, and then the next time we're going to do the opposite thing first. So it says translate and reflect. Then we are going to reflect and translate to see how they compare. So first, we will translate. It's like a little man missing his legs. A little stick figure. And don't forget we need to extend that vector. So we will translate him. And then we need to copy the line so we can reflect him. It's okay that we don't have the full line as long as we get one endpoint to match up. So we're going to flip him over and make sure that this endpoint matches up with the end of that one. And then we are going to retrace our little man. So this would be S prime. And that was when we translated and reflected. Now we're going to do the other version. So we are going to reflect first this time. So reflect. And then we will translate along this vector and replace our man on the page. And we'll call him S double prime. How do they compare? Are they the same? Does the order matter? Number 2 says, let L1 and L2 be parallel lines, and let the reflection of 1 and reflection of 2 be across 1 and across 2, in that order. Then show them in the opposite order. So what we're going to do is we're going to take points on the lines and reflect them to see where they end up. We're going to start with 1, then 2, and then the second time we're going to do 2 and then 1. So there's my points on there. So we're reflecting across 1, and then we're going to reflect across line 2. And our points ended up down here. I should have labeled, let's see, 1, 2. So when we went across 1 and then back over 2, this would be 0.1 prime and this would be 2 prime. Now we are going to do the same thing, but we're going to go in the opposite order. So first we're going to reflect over line 2. Oops, I need a longer piece of tracing paper. Okay, so first over line 2, then over line 1, and my points end up way up here. 1 double prime, 2 double prime. And so show that the reflection is not equal. We've done that because these points don't end up in the same spot. Okay. Number 3 says let L1 and L2 be parallel lines and let the reflection of 1 and 2, meaning in that order. Can you guess what reflection followed by reflection, what a reflection 1 followed by a reflection 2 is? Give a persuasive argument. Give as persuasive an argument as you can. Examine the work you just finished in the last problem. So it's going to be very similar. But what it's saying is, can you guess what it would look like? Well, if we were to take 1 and 2 and then slide them up to match with those, we could use a translation instead of a reflection, and we would translate them along a vector that would go from 1 to 1 double prime. You may notice that this line looks perpendicular, like it creates a right angle. So down here in number 3, can you guess what a reflection 1 followed by a reflection 2 is? That was the first one. And it would be a reflection down in a perpendicular direction. Or not a reflection, a translation. Translate down, perpendicular to the lines. That's another way that we could get from point 1 to 1 prime, is to translate perpendicularly down. And it does appear to be twice the distance. If we were to take this distance here and copy it, it'll be twice the distance between those lines in a perpendicular direction.